Hey folks, we are back with 8.2 here. We learned how to write our hypotheses and check our conditions last time when working with means. Today we're going to go over how to calculate the p-values and how to make the conclusions of our hypothesis test. All right, so just like before, our p-value is a probability. It's the specific probability of getting the sample data that we get or something more extreme. So or something farther away if the null hypothesis is true. So we take the null hypothesis to be true, and then we just go from there to find the probability. All right. Then we compare our p-value with an alpha value, which we usually use 5% for, just like we did when we use proportions last unit. If our p is low, we reject the hoe. If our p is greater than or equal to alpha, we fail to reject the hoe. And by low, of course, we mean less than alpha. So here are the here's the steps to do that for this one. First, we state our hypotheses. We'll have our null hypothesis that the mean equals some number. We'll have our alternative hypothesis. Maybe it's greater than, maybe it's less than, maybe it's not equal to whatever number that was. All right, we will need to state the values of our sample mean, our standard deviation, and n. The mean, of course, will be the null hypothesis mean. We're going to use some of these, like the mean, to calculate the mean of this sampling distribution, because that's what we're going to work with, is a sampling distribution. And we need to come up with the standard deviation, which is the standard deviation divided by the square root of n, our sample size. Then we're going to draw our normal curve, just like we did with p's. We're going to label the mean right in the middle. We're going to label wherever our sample mean is, x bar, and then we're going to shade going away from the mean, just like last time. So in the opposite direction from the mean. And then we'll use normal CDF to find that probability, and that probability will be our p-value. All right, so we've got a few examples coming up, but that's all I've got left here is just examples. All right, so in 2014, the mean price of a gallon of gas in California was $3.80, with a standard deviation of 39 cents. To see if the mean gas price has increased significantly, we take a random sample of 40 gas prices and find they have a mean of 4.25. Is there significant evidence of an increase in gas prices from 2014? All right, so the first thing we're going to need is, well, we're going to need to know what mean stands for here. It's the true mean gas price in California in 2022, I guess is what we're in now. Our null hypothesis will be that the mean equals whatever we were given to start, which is $3.80. Our alternative hypothesis is the mean has increased. It was now greater than $3.80. And we can write down any other things we have, like we were given a standard deviation of 0.39. That was this guy right here. We're given a sample size of 40. And we're given a sample mean, an x bar of 425. All right, next we need to, let's see, okay, I guess that's all that right there. There we go, did it all right there. Sample and population statistics. Now we need to find the mean and standard deviation of the sampling distribution. So the mean of the sampling distribution will be equal to the mean from the null hypothesis, 380. The standard deviation of the sampling distribution is the standard deviation here, 0.39, divided by the square root of our sample size, in which case it is 40 here. And we're going to need to work that out. So we'll pull up our calculator here. And we'll turn it on because it's turned off while we were waiting. So 0.39 divided by the square root of 40. And that gives us 0.0616. So 0.0616. We do want to keep a few decimal places there if we can. Next, we have a normal distribution now. The reason we actually know we have a normal distribution is because our sample size 40 is greater than 30, so the central limit theorem tells us that that holds true. So we're at 3.80, and then we've got a sample statistic of 425 way up here. and we're going to go away from the mean, so we're going up in that direction. And this little section here, that will be our p-value. To find that, we're going to use the normal CDF. Our lower bound here will be where this section starts at the 425. Our upper bound is just going to be something big like 100. Our mean is the 380. And the standard deviation is the sampling standard deviation. It's this guy down here, 0.0616. I have a feeling we're going to get a very small p-value here, but that is okay. That happens. Looks like gas prices have probably gone up. So second distribution, normal CDF. Our lower bound is 425. Our upper bound is just something big. I went with 100. Our mean is 380. Our null hypothesis mean. Our standard deviation is the sampling standard deviation, 0.0616. And enter a couple times. And if you look here, that has a negative 13 at the end. So that's 1.39 times 10 to the negative 13. All right, that means there's 13 zeros in front of there. So that means our p-value is essentially 0. All right, so that means our p-value 0 is less than any sort of alpha we could do, in this case 0.05. So we are going to reject the null hypothesis. We have evidence that the mean is now greater than 380. Pretty good evidence. All right. Let's try 2 more here. And let's change up the color a little bit. Blue. All right, so back to our example from last time. The mean weight of a high school football player is 185 with a standard deviation of 25 pounds. We believe the mean has increased, so we take a random sample of 100 high school football players, and we find that the new mean is 190. So we already did the defining of mean before, so I'm going to skip that part. Our null hypothesis is that the mean is 185. An alternative is that it has increased from 185. And let's see, our other information is that the standard deviation, the population standard deviation is 25. Our sample size is 100. Our sample mean is 190. All right, so now we need the mean and the standard deviation of our sampling distribution. So mu sub x bar is, well, it's the null hypothesis, 185. Sigma sub x bar is our standard deviation, 25, divided by the square root of our sample size. So that's going to give us, I believe, 2.5. And now we're going to have a normal distribution. And let's see, we've got 185 right here in the middle. And 190 is going to be up here. And we're going to go up from there because our alternative hypothesis is that it has increased. So to find that, we're going to use normal CDF. Our lower bound will be the 190. Our upper bound will be just something big. Let's try 1,000. Our mean is our null hypothesis mean, 185. And our standard deviation is our sampling standard deviation, 2.5. And let's see what we get in our calculator for that one. So second distribution, normal CDF number 2, 190. And something big here, like 1,000 or 10,000 or 1,000,000. Then 185, and then 2.5. And we're going to get 0.02. All right, we just really need the first 2 digits, 0.02. There's our p-value. All right, so that is definitely less than 0.05, so that means we would reject the hoe. All right, looks like we have evidence that the mean has increased. All right, so there's the football example, and we'll switch to purple here for this last one here. So the mean number of days a student is absent in the 2018-2019 school year was 8.5 days with a standard deviation of 6. We believe the mean has changed. So we take a sample of 60 students, and they have a mean of 9.3 days absent. All right, so let's see. Our null hypothesis here is that the mean is equal to 8.5 like it was before. Our alternative is that the mean has changed, so not equal to 8.5. So this is two-sided. That means once we get our our area here, we have to double it to get our p-value. All right, but we'll get to that in a second. So the standard deviation is 6. The sample was of 60 students, so that's n is 60. And our sample mean x bar is 9.3. All right, so let's see. The mean of our sampling distribution is this null hypothesis mean, 8.5. The standard deviation of our sampling distribution is our standard deviation of 6 divided by the square root of 60, our sample size. I can't do that one in my head, so let's do it on the calculator. So we got 6 divided by the square root, so second square root 60, and we get 0.77459, so 0.77459, there we go. And let's see, we draw our normal curve. All right, we're going to put 8.5 here in the middle because it's the mean. Our sample statistic was 9.3, that's up here, 9.3. We want to find this area here to start, so to do that, we're going to use normal CDF. The lower bound, well, that starts at 9.3, so we're going to go from 9.3, and we're going to go up to something big, like 1,000. Our mean is 8.5. Our standard deviation is 0.77459. I don't know if we need that many digits, but we've got them, so we might as well use them. Second distribution, normal CDF. Let's see, 9.3 for our lower bound, something big for our upper bound. We've got that. 8.5 for our mean, and then 0.77459 for our standard deviation, and that gives us 0.15. All right, so now that is not our p-value because this is a two-sided test, not equal to. So we could actually go just as far over in this direction, and we have this area over here as well would be this far away from the mean or farther away. All right, so we actually double it. So this is 0.15. So our p-value here is 2 times 0.15, which is 0.30. All right, so that means our p-value is greater than alpha. And even if we didn't double it, it was still greater than alpha. So we do not reject our HO. All right. Now, I noticed we didn't do any examples where we went down. If we do go down, the lower bound needs to be something negative, like negative 1,000 if we do end up going down, like doing this section down here. So don't forget to go negative numbers for lower bound, and then your upper bound would be your sample statistic there. All right, so that is it for 8.2. Go ahead and turn in your notes and get started on the homework assignment.